So, hi, hello guys, good morning. So, today we are going to discuss about this long stringent problem on lead code. So, the problem is something like this, that we are given a list of words and we have to find the longest string chain. So, for example, let's read the problem here. Given the list of words, each word consists of English lowercase letters. Let's say word 1 is predecessor of word 2 if and only if we can add exactly one letter anywhere in the word to make it equal to word 2. So here ABC is predecessor of ABAC because we can create ABAC by adding the letter B in ABC. Similarly, if we have a letter something as ABDC, that will also be the predecessor. AB, if we have here ABDC, then ABC would be predecessor of ABDC. The order of the words letters, the order of letters should be same in the word and its predecessor. So we have to find the word chain which is the longest. So for example, the here we have to find the string chain. Let me just go to my GitHub page for better explanation. Okay, so here we have AB, BA, BCA, and this is the string chain. So if we consider this as a graph, at top I have taken the biggest word, so it's BDCA. So from BDCA, if we replace B, if we like remove B, we'll have DCA. So yes, DCA is a valid uh, predecessor. So there is a path from word to its predecessor. If we remove D from here, it will have BCA. So BCA is also a valid predecessor. So there is a path in graph from BDCA to BCA. Now if I remove C from here, I'll have BDA. So that's also a valid predecessor because BDA exists in the chain, in the input words. So I'll have one path to BDA. And if I remove A here, so BDC, it's not a valid predecessor because BDC doesn't exist in this input string of words. So until here we have created this graph. Now we'll be using depth first search. So whenever we find a word which is predecessor of any particular word in the graph, we'll jump to that word. So BCA, for BCA we'll just remove B. So in that case I'll have CA. So CA is not a valid predecessor because CA does not exist in this input string. Then I'll remove C. So it comes BA. So BA is a valid word. So I have just one path from BCA to BA. And on BA, if I remove B, I'll have A, which is a valid predecessor. And if I remove A, I'll have B, which is again a valid predecessor. So this is the longest string path, that is this one here. Either maybe this one, either maybe this one. And from BDA as well, if I remove B, we'll have DA, which is not a valid predecessor, so no node connected to BDA as DA. Then if I remove D, I'll have BA, which is a valid predecessor, so it joins to the same node. So BCA and BDA connects to same node BA, and then we have BA. So this is how we uh, will create a depth first search graph traversal on these string of words, considering them as the graph nodes. And the longest string chain length might be from BCA. All we can return any one. This is BDCA, BCA, BA, and A, or maybe BDCA, BA, and B, or we can return this from BCA, passing from BCA, or passing from BA, BDA, and so on. So I think you might have now got the question here. So similarly, we can we'll return this one. So now the one more case here is that if the length of the word is only one. For example, if words is equal to A, so in that case we have to return one because the longest word chain in that case will be 1 only. So now we are going to solve this problem with the DFS, recursion and memoization. So how we are going to solve it? So first of all, we'll be creating, so we have these words, and these words are provided in um, string, vector of string. So we will create an unordered set from it. um, we'll create an ordered set because access from an ordered set will take O1 time, but if we want to search a word in um, vector of string, it will be On. So for the time complexity, an ordered set will be created. Then we'll perform the depth first search on every word. So whenever we find a word, for example, we are doing a depth first search on BDCA, and we remove first entry, that is B, we find DCA, so we'll jump to that word, this one DCA, and then again we'll perform a depth first search on DCA. Now if after removing the first letter from DCA we cannot find CA, after removing second letter we cannot find DA, after removing third letter we cannot find anything, so we'll update the length of the longest um, subsequence till DCA in an unordered map, and then we'll jump to the next word in the sequence. So after removing B we have got this, so after removing D we'll got BCA. So on BCA, after removing B we do not get anything, after removing C we get BA, so we'll jump to BA, and then we'll perform a depth first search on BA itself. So this is how the logic goes. So we have to create a subword from the word. For example, the word is XBC, so subwords are BC, that is we have removed X. Then we have removed B, so it will be XC. Then we have removed C, so it will be XB. And then you have to search each subword in the unordered set. If subword is found, we take the word equal to subword and perform depth first search on the subword, and the max length variable for the subword is found and noted. So we have an ordered, we'll also take an ordered map where string would be the word. I'll just explain the working of an ordered map here in this diagram. And it stores the longest string chain present in that word, taking that word at end. So for example, in an ordered map, the key would be string and value would be the length of the string chain ending at that key. So for example here A, the length would be 1 because we cannot have any string chain ending at A greater than length 1. Then if we have B, BA, so we will have the length as 2 because we can have two string chains ending at BA and which are both present in the input words here BA and A both are present. Then we'll have BCA, so in this case we'll have the value as 3, the length of longest string chain is 3 because BCA, from BCA BA can be taken, and from BA B can be taken and A can be taken. Since BCA BA everything is present in the input word, so the value of this key BCA in the unordered map will be 3. And similarly for BDA, because sorry, it's the typo here, so for BDA if we remove D here, so we'll have BA, B and A, so every word is present here. So let me go into the logic here, maybe here I think. So we'll start from main. So input might be this one, so I go into the longest string chain. Now in longest string chain, so this vector is vector of string. I have taken this as vector of string. So now I have, in step 1 I have just created an unordered set. This is US is an unordered set of words. This one, so US is an unordered set of words. I have created an unordered set just by inserting every input value from the input words, this one. Then then I'm doing the depth first search on every word. So, and I'm finding out the longest length after performing the depth first search. So I'm going into the each word. I'm doing depth first search for each word I here. So let us go into depth first search. So now in depth first search, every word is received. So if word is present in the unordered map, so the value is returned. And benefit of this unordered map is that we do not have to calculate the substring again and again. So for example, when the first word BA, when we find the BA for first time, this one, the value of the value 2 is stored for TBA, that is this one will be stored. So when next time we find BA, we can simply return 2 from this unordered map. So if we have not taken this unordered map, then we have to do again traverse through the entire list of words and then find the value, that is this one BA value for this key. So this again traversal into subtree or maybe into the list of words um, is avoided, and this is what we say as memoization. So as of now, for the first word, that is XBC, this unordered map would be empty, so it will not go inside. So now I'm going to every letter of a word. So word.length would be 3 here because we are taking XBC here. So I'm taking a subword from here. So first subword would be BC because I'm taking a substring from 0 to I. The I is 0 here, so this will not return anything. It will return from 0 to 1. So substring from 0 to 1. So it will be BC. So now I'll search this substring in the unordered set which I have taken in step 1, and if I do not find a substring in the unordered set of words, if I find the substring in the unordered set of words, that means let me remove X. I do not find BC, let me remove B. I do not find XC, let me remove C. I find XB here in the word. So what I'll do is I'll perform a depth first search on this subword. So I'll pass this XB onto the depth first search function. So again, the similar process for the word XB is performed here, and by default, this function DFS will return 1 because we can have the substring or the longest string chain for any word as 1, so it will keep on adding, and finally we are going to return the length, the max length of this one of max length and the length returned by the DFS, and the output would be returned from IOUT, which is taken as the max of IOUT and depth first search. So again, please note that we will be performing depth first search for every word. So first of all, we have performed depth first search for XBC, then perform depth first search for this one. But the benefit would be here would be the unordered map, because for XB we have already noted that the longest string chain ending at XB would be 2. So in this case, whenever we find XB after like if we are on a depth first search of this word, we are removing every letter out of it and we go on to XB. So in that case, this condition will fall true and it will return 2 in that case. So we do not have to again go through the XB and find the subwords. So for the complexity calculations, let us assume there are n number of words. So here we have 1, 2, 3, 4, 5, 6, 7 words, and length of the longest word is L. So this is 4. So now in this case, time complexity would be that first of all it's On because we are creating an unordered map here, unordered set here by iterating through every word. So it will be On. Then we'll be iterating through each word to find the neighbor in this for loop. So it will be on again, on plus on, because these two loops are not nested, so it will be on plus on. Then we are going to find the next connected word to each word. So I'm going through this one. So this for loop and this for loop, these are nested. So this depth first search contains a for loop, and this is the outer for loop here. So it will be, in this case, NL square, right? So length of each word multiplied by um, every word in the depth first search. So it will be NL square here. So the time complexity will be n plus NL square, and the space complexity would be 2on, because an ordered map will also have and may also have n entries, and an ordered set will have n entries, but space complexity we can say O of 2n is O of n only. So this is how, like, um, so this is an accepted solution, accepted of mine. So thanks a lot, guys. Thanks a lot for watching the video, and if you have any questions regarding this long string chain problem, just post it in the comments. I'll try to answer the questions. Thanks a lot. Have a good day. Bye.